Yeah, thanks a lot, Jen. Yeah, as the second speaker of the day, I will hand over from Jen to talk about a little bit on uh, the capabilities of the LLMs for the specific data science questions. So let me share my screen. And yeah, hopefully it is visible at that moment for everyone. I'm going to walk through with my little history about play about these type of tools for the last 2 years, I would say. The first question is basically, are they good enough to do some data science or the data science related tasks? I mean, to some extent, we can say yes, but of course, we need to be aware of the limitations and the capabilities at the same time, I would say. As you know, doing a first time in the TALMO audience, I would say a little bit about me. I'm a teaching fellow in statistics at the School of Mathematics at the University of Edinburgh and teaching since 2022. Beyond the teaching roles, I'm happy to collaborate with other colleagues to co-organize different things, as Jen mentioned at the end of her talk, basically, and hoping to see some of you in the July workshop as well. And going back to my interest on the LLMs, after the classical date that we can remind ourselves all the time, the November 2022, it's a very interesting moment that we experience. So many things are happened, I would say, especially for the programming related courses. There are some really neat books already out there just to use LLMs as a kind of helper, possibly. And the AI, even if the AI assisted coding is not a new concept, actually, they are heavily impacted by the recent advancements in the Gen AI. Specifically, there are two streams, like using these tools as helper on code writing. This is going to be one of the options that we can think about, or using these tools to do data analysis directly, especially some plugins or extensions of the LLM companies like the OpenAI's ChatGPT data analysis. I guess this is very common at that moment for other, let's say, competitors as well. We can easily upload our data and ask a couple of questions about the data sets immediately. And behind the scene, it can run some code and give us, let's say, a reasonable suggestions or outcomes to some extent. Beyond these efforts, I would say, since statistics and data science naturally includes programming languages, I guess many people are started to look around, how it is possible to embed into teaching and the learning process to some extent. These are some earlier studies, specifically starting from 2023. I mean, there are some many texts in my slides, so I'm not going to talk about all of them, but just try to give a light touch on some important aspects. Specifically, ChatGPT integrated data analysis concept thrown by this author here, because basically, as long as we can get help from these tools, our communication with the machines to some extent is actually changing at that moment. So rather than writing a code, we can use a natural language to get some results from these tools. This is happening at that moment. What we discovered or what we experienced so far, specifically how those tools are, let's say, operating or performing on the data science tasks, such as the pre-processing or EDA or the modeling. This is also related to automation in the data science field. And I would like to talk about a little bit my little history, sparking my interest, and also what we are doing at that moment, especially how LLMs can be implemented for the data science field. Starting from the initial personal efforts, 2023, I just looked at our data science course multiple choice question quizzes for certain and reasonable reasons that you can imagine. We are asking already a question including some options. So those tools are really good at really excelling on answering questions whenever we give more input. So from that perspective, looking at the course assessment side a little bit, I just did some small experiments on the weekly auto-marked quiz questions that we are using for IDS. And my initial idea was, looking at different LLMs and how they are performing on certain type of questions in the quizzes that we created, and to see a kind of a, let's say, rough comparison. at that moment, there was a tool called 3.5 for, even the Google's tool was not called as Gemini, a little bit, old enough, I would say. But looking at their, let's say, performance comparison and also how they did compared to our students, I looked at what we are going to do for the next semester, and we decided to change a couple of questions regarding the quiz contents. And in those days, we didn't know that these are just very naive and humble approaches. I would say. I guess nowadays, whatever we are asking as a multiple choice question, especially the recent models, they are doing better and better from that perspective. So this is a kind of the data science course quizzes, let's say, types that I manually created and also implemented within the ChatGPT or alike, and looked at the general performances, kind of asking directly the question itself, even if the type is changing from yes or no, or the question including some data operation or data processing or analyzing, or the classical knowledge base multiple choice questions. We observed that a couple of, let's say, different performances across different LLMs. And even when we look at the overall performance of our students in this actually academic semester, it's supposed to be 22, 23. These are the news that, they are really doing good, and it's going to be really better. And specifically beyond the multiple choice questions, when we ask very data analysis related queries, directly uploading your data set, we can see that nowadays so many tools are out there, in addition to GPT's data analysis, previously called as code interpreter or some other namings as well. And then I switched to my experiments to that direction a little bit, beyond the quiz exercises, because we are already using some open-ended questions relying on certain real-life data in the, let's say, homework examples or the group projects as well. And we would like to see how they are, performing in this area as well. I guess it is a very important difference, either you are using some code interpreter tool behind the scene or just directly relying on the original LLM itself. But in the first trials or the first experiment that we did with one of the colleagues in the school, we decided to check a couple of, let's say, data science lifecycle related tasks by asking very simple prompts like the zero-shot learning to see their performance without creating any complicated or any, let's say, specific prompt. It was like, okay, I had the data set, like mimicking maybe a novice learner or, let's say, the student struggling with where to start, just uploading the data and asking to LLM or ChatGPT, let's say, this is my data. I need to create some, data analysis report. How can I start, or what can I do? We just simply stick these type of prompts at the beginning and to ask certain questions related to supervised or unsupervised learning questions, relying on two main data sets. One is specifically used, the laptop price data is specifically used for some data visualization, let's say discussion. And the other one, Duke Forest, is coming from an open source R package, Open Intro. We experimented this one as well for the modeling purposes. For the evaluation aspect, what we did very basically, looking at the, after asking the question, getting the output, looking at the output itself and evaluate it in terms of a kind of, let's say, a star system. Out of 5, we were giving some number of stars in terms of, how the tool is performed, and is it really, conveying the real message that we are looking for, or if it is a data visualization, is it really a valid visualization? And these type of details can be discussed between me and Miguel, and we try to give some star for each of them. How it looks like, I'm going to show you a couple of examples visually as well, but in these initial experiments, there was no specific metric that we are using. And nowadays, we are trying to looking at the other direction as well. Considering the initial observations, I would say the general suggestions are really good enough to start with. you can see some very good pre-processing suggestions, or even, let's say, the modeling suggestions without asking very specific prompt or query. Even if one of the powerful aspects of the data analysis extension of GPT is actually excelling at generating data visualization and actually executing the successive analysis, for some visualizations and the related interpretations, it might be still, incorrect and misleading, as Jen mentioned previously. So whatever I'm getting from the model can be useful to some extent, but at the same time, I need to know what I'm doing, as you can guess. So especially the users who are not familiar with the suggested models, it can be a little bit problematic and tricky. And from the teaching and learning perspective, I would say, without knowing, let's say, the certain aspects of the regression modeling, or how it, works, directly getting answers can be really bypassing the learning process or path in any way. So whatever we are, injecting through our teaching and learning delivery, I would say, we need to be aware of these type of details as well. So overall performance were okay, I would say, but looking at the individual ones, we can see different stars, such as the next slide that I'm trying to highlight. For the histogram example, for instance, what we observed basically, even if the original range is not logarithmic scale, it is just randomly, putting in the log scale price rather than the price itself. It was a little bit surprising in those days. But of course, this is just one let's say, one prompt asking, so one query sending, rather than investigating in depth. But on the other side, if you look at the multiple bar plots for the categorical variables belonging to data, it was very good at creating some distribution of the prices across different categorical variables. In addition to these visualizations, we also try to evaluate let's say, the text style outcomes, such as the correlation analysis summary. It's actually, broadly speaking, telling us what it means when I get 1 or -1 or 0, but without, let's say, mentioning about which type of correlation it's used, for instance. So potentially, these type of nuances or details can require more specific prompts, or a follow-up communication with the tool, as long as we know, what we are looking for or searching for. All those initial efforts actually bring us a kind of an idea regarding the, the fact that there's an inherent randomness of those models. We know that it is not about, directly creating or extracting a knowledge, and alternatively, what they are doing is basically kind of a prediction of the next token to some extent. So from that critical perspective, we started to think about, what we can get when we ask these type of prompts repeatedly. And nowadays, we are working on a joint project with the Miguel de Carvalho from the school, and one PhD student as well, to assess and evaluate the performance of a data analytics tool, looking at the data science tasks, such as data wrangling, EDA, or fitting the models and interpretation of the models as well. And within this framework, still, we are interested in actually trying to see the impacts of different style of prompts, such as the clear prompt or the unclear prompt. It could be, again, a kind of direct asking question, which can be called a zero shot from the terminological perspective. So we can try to, get these type of nuances. This is going to be our main motivation nowadays, working on this project. And so far, what we did, basically looking at a couple of repeated promptings for the certain, let's say, data science related tasks. Again, just to highlight a couple of initial observations on repeated prompting, what we tried, basically asking the same prompt 10 times. As we can imagine, because of the randomness, we can get different structure, different texts of writing, and from time to time, different, results, including some data visualization details as well. Specifically, the correlation heat map example was very surprising. Even if it can create the heat map by calculating the correlation, when you compare with the numbers written in the narrative or the interpretation, sometimes do not match with the correlation values in the original data visualization outcome. For the histograms, for instance, from time to time, it is randomly adding the density curve, or sometimes adding certain summary statistics as the vertical dashed lines without asking it, basically. These type of randomness can appear. So that's highlights that either we need to be more specific while writing the prompts, or we need to add some kind of maybe conditioning behind the scenes, like the system prompts or so. Otherwise, it can be very, different for the learners from the teaching perspective as well. What we did very specifically, following the, let's say, reviewer suggestions, for very specific or complicated visualizations, such as the mosaic plot on the categorical variables, we did the same experiment. And specifically from the color choice or label position and these type of details, what we got is really not readable, I would say. What I'm saying is not readable looks like the following. So without very specific prompting, without specifically, describing what should be my categories and what should be, let's say, the final outcome regarding the color and so on, it is creating some visualizations, including this one, having so many, difficulties regarding the readability and also interpretability as well. And from the data visualization design perspective, I would say this is also problematic to some extent. So these initial, let's say, repeated experiment nowadays continuing to some extent. In the last project that we are working together at that moment, we were interested in, during the last year, let's say, how we can measure and how we can bring some metric for these type of questions, including even the open-ended style data science relevant questions. After looking at the discussions about the automation in the data science and some other works recently, we realized that, not surprisingly, but to some extent, luckily, there are some examples on this similar direction or similar stream. Some people try to evaluate these performances by creating their own, let's say, testing data, generally called as the benchmarking. If you're, interested in more on the technical side of LLMs, I would say you already heard about some mathematical related tasks or code related tasks. People were mainly using these benchmarks to evaluate the overall performance whenever a new version of the LLM comes into play. And this is happening at the same time for some data science related tasks. These are some examples that I created, and mainly speaking, all of them are looking at the certain number of specific prompts, like different difficulty levels, and looking at different data science tasks, and trying to actually evaluate the performance of different LLMs by looking at individual metrics. But of course, it might change when we look at the certain, let's say, data science task. Either I'm interested in the data pre-processing or interested in data visualization or the model interpretation, I would say. Nowadays, we started to work around, what should be our created data sets to actually contribute in that direction by closing the gaps of, let's say, specifically when we ask statistics related or the modeling related questions. So far, many of the benchmarking solely focusing on actually the classical metrics like R-square value or root mean square error and these type of things. And in my understanding so far, no one looked at, for instance, the model diagnostic plots and also their interpretation. And especially when we do this repeatedly, we expect to see, some, let's say, deviation from the interpretation and the created visualization. And we are going to try actually close these gaps from the statistical point of view. In addition, we are aiming to, let's say, test whether, the clear or unclear prompt is affecting how much when we ask the same thing repeatedly by mimicking the Monte Carlo idea a little bit and trying to collect all those together to give a general overview. high-level overview of their performances on specific data science tasks. These are the recent plans so far. I just mentioned a little bit, but especially the main idea itself within that project, like creating the human written prompts, borrowing from our course examples and also the open source exercises, and creating our new ones as a team, and specifically touching on both supervised and unsupervised learning landscape, and trying to understand actually how they are performing under different tasks regarding the metrics that we are proposing. The other idea, the possible idea could be like in addition to the model diagnostic, for instance, how about the created code is, really robust enough regarding the data leakage issue, if it is a kind of machine learning, let's say, task. So we are gonna examine in this direction. Just to bring actually a couple of ideas and a couple of recent news to complete my talk by adding more details about the curriculum, let's say, injection to some extent. There are some recent reports in the kind of a survey result coming from the Anthropic company, is highlighting that, this is a report from 2025. We are living at that moment, let's say. AI is increasingly embedded in everyday life, they claim, and they became more efficient, affordable, accessible. That means that it is a kind of inevitable to see that students are using it. As long as we experience, for the last couple of years, possibly they are going to use different tools for different purposes as well. Even if the complex reasoning remains a challenge for these type of tools, whenever we are, feeding the system with the instruction or guidance, like we did in our homeworks or let's say the assessments, it is easy to some extent cheat from that point of view. My personal opinion on this, I mean, if we just leave them alone and play around whatever they are picking up, this is happening, and it's going to happen regularly, I would say. From that perspective, I believe what we need to do is using these tools in a more systematic way within our teaching delivery, and even actually using not the original tools, but maybe the variation of tools which is pedagogically designed for the course that we are delivering. There are some examples in the literature, so I guess these type of course-specific examples are going to increase because it looks like the mathematical reasoning and coding performances are getting very high. Even the closed source model or even the open source model looks like. But especially when we look at the Anthropic study, how university students use cloud, they actually analyze their conversation data behind the scenes in an anonymized way. And they were highlighting that students are using roughly, I would say 25% belonging to the overall conversations as a percentage, direct problem solving, direct output creation, collaborative problem solving, and collaborative output creation. There's a kind of indication that they are asking directly the question itself and getting the result immediately. So this raises the concerns and questions about, the academic integrity, possibly, because if we have the multiple choice question, off-class style, or the homework take-home style, let's say assessment, possibly they are using it already, and especially using many different tools that we cannot easily detect or almost impossible to detect. And the other take-home message from this study as well, lying in the last paragraph, they are mainly using these tools for creating and analyzing, and especially from the Bloom's taxonomy, they highlighted that they are giving actually the cognitive or the critical cognitive tasks to AI systems. This is very recent, by the way, just from yesterday, they announced it. So assuming that, not assuming that actually, observing that OpenAI and Anthropic or us are also targeting college or university students to make their system are almost freely available, like OpenAI announced in May, they are going to release Plus membership for some college students in US and Canada as a free tool. and Anthropic is trying to fight in this direction as well. So we need to do some actually let's say clever injections of these tools are for our teaching and teaching statistics and data science courses, I would say. These are a couple of ideas that I have been thinking recently. There are some examples of having a help from chatbots specifically designed for specific courses, such as the computer science or even the data science belonging to 2024, if I'm not wrong. There are some initial, let's say, efforts on that direction. What I have been thinking for my course, for instance, for the IDS, we were giving some guidance on the GitHub comments, but even the lecturers and tutors, just to admit, we are searching and trying to find the best suggestions for it. What I have been imagining, like we can maybe create some kind of a helper to help for all of us, especially for the topics which are not lying on the primary learning outcome of the course, I would say. There are some R packages as well, allowing to interact with the LLMs already. Even the POSIT company itself announced something. So from that point of view, statistic courses with R programming a kind of subject to change in the near future. This is my, let's say, personal humble guess. But in the same time, we can also benefit from some technical terminologies from the LLM landscape to create maybe a more, let's say, sophisticated or more interactive teaching delivery, such as the different workshop style. By mimicking the reinforcement learning with human feedback, for instance, we can create some specific workshop, let's say, designed through the semester so that we can collaborate more on certain topics and by using certain tools. And the other idea could be like, as an offline helper, trying to simulate the kind of a student-instructor interaction, like the in-class conversation simulation beforehand, so that we can be more prepared what's going to happen in the class. So this is the related items that I benefited from. So if you're interested in, and thanks for your participation and thanks for listening to me, and happy to have your follow-up questions later. I suppose later, but please correct me if I'm saying something misleading.
Yeah, so maybe we have time for 1 or 2 questions, and then we'll take a short 5-minute break. I'll put the Mentimeter also in the chat, just so you can answer the questions during the break. Or if you prefer typing any questions into the chat, please do so.
Yeah, there was a question from you or Alistair, Jen? Like
I replied to Alistair. So.
Okay, so that just... Yeah, as far as I know, for the pre-processing, it is difficult to say, what it is doing really accurate. And even for those metrics relevant to pre-processing side, in one of the papers that I know, they are trying to, evaluate that performance as well. Just, kind of a matching with the ground truth, if it is available, and what LLM produced.
Yeah, that's a really good question. So just to highlight that again, Alistair asked, how would we know if the pre-processing by generative AI is accurate or if it's just hallucinating? So I put a few suggestions in the chat. And we also have a question whether you could put your reading slide back up, please, Ozan. And we'll take a quick 5-minute break and reconvene at 5 past.